VSIM uses the concept of desired speeds. Vehicles are given a desired speed distribution, and each particular vehicle will have a specific desired speed within the distribution. This becomes the free flow speed for that vehicle, the speed the vehicle will travel at with a small oscillation, if not hindered by other vehicles or other network elements. Any vehicle with a higher desired speed than its current travel speed will be incurring delay, and therefore will be checking for the opportunity to pass without endangering other vehicles. To create a desired speed distribution, on the menu bar select Base Data, Distributions, Desired Speed. In the resulting dialog box, select New to create a new desired speed distribution. The minimum and maximum values for the desired speed distribution are entered in the two fields above the graph. The minimum value in the left field must always be less than the maximum value, so if you are increasing both values, you should generally increase the maximum value first. In the graph, the horizontal axis depicts the desired speed, and the vertical axis depicts the cumulative percentage from 0 to 1. Let's create a new desired speed distribution with a minimum value of 35 miles per hour, a max of 45 miles per hour, and an 85th percentile speed of 40 miles per hour. First, change the right field to 45 miles per hour. Then change the left field to 35 miles per hour. You'll notice that a red intermediate point is created. You can delete intermediate points by dragging them to the upper right corner of the graph. You can create intermediate points with a single right mouse click. To move an intermediate point, simply left-click and drag. Merging two intermediate points by dragging one on top of another will delete the first point. Now, let's create an intermediate point at the 85th percentile at a speed of 40 miles per hour. Right-click on the line to create the intermediate point, and then drag the point until the horizontal axis shows a speed of 40 miles per hour, and the vertical axis shows 0.85. Generally, if the speed limit is 40 miles per hour, a smaller percentage of the traffic will have a desired speed that is much less than 40 miles per hour. So let's create another intermediate point to lower the percentage of vehicles that will be given a desired speed less than 37 miles per hour. Right-click on the line to create another intermediate point, and then drag the point until the horizontal axis shows a speed of 37 miles per hour, and the vertical axis shows 0.15. This means that only 15% of vehicles given this speed distribution will have desired speeds less than 37 miles per hour. 70% of the vehicles will be given desired speeds between 37 and 40 miles per hour, and 15% between 40 and 45 miles per hour. If you do not have speed profiles for the area that you are modeling and you do not have any conflicting speed information about the area, a good rule of thumb is to choose min and max values that are plus or minus 10% of the speed limit, with the speed limit set as the 85th percentile speed. Let's create another desired speed profile with a minimum of 25 miles per hour, a maximum of 35 miles per hour, and intermediate points at 27 miles per hour for 15% and 30 miles per hour for 85%. In VSIM, there are three ways to define which desired speed distribution vehicles should use. The first is to define the desired speed distribution for the vehicles entering the network. We'll cover this in detail in the next section, Traffic Compositions. The other two ways to define the desired speed of vehicles allow you to change the desired speed of a vehicle that is already in the network. Desired speed decisions are entered per lane at a point and will permanently change the desired speed of the vehicles that cross it, or until another desired speed decision is crossed. Reduced speed areas are also entered per lane but have a length associated with them and will change the desired speed of the vehicle only for the length of the desired speed area. The vehicles will revert to their prior desired speeds after crossing the end of the desired speed area. Another big difference between these two network elements is that with reduced speed areas, a vehicle will automatically decelerate prior to the start of the reduced speed area, such that the vehicle will be traveling at the speed defined for that reduced speed area once it crosses the start of the reduced speed area. Therefore, desired speed decisions are used primarily for changes in speed limits, such as when a vehicle turns onto a different roadway with a different speed limit, and reduced speed areas are used primarily for curves and turning speeds. In our network, the north-south roadway has a speed limit of 40 miles per hour, and the east-west roadway has a speed limit of 30 miles per hour. Let's put in speed decisions to change the speed of the vehicles as they turn onto a roadway with a different speed limit. To make it easier to see where to create these speed decisions, we will switch to centerline view by selecting Control-A so that we can see the background image in which we have added lines and numbers to indicate where each speed decision should be placed in this network. To create a speed decision, first select the Speed Decision icon on the toolbar. The Speed Decision icon is the red circle with a 50 inside it. Now, left-click on the southbound link leaving the intersection to select the link, and then right-click on point 1. In the resulting dialog box, select New to define the desired speed distribution by vehicle class. Since the north-south roadway has a speed limit of 40 miles per hour, the default values here, which choose the first value in the lists, are correct. This will change the desired speed of vehicle class cars crossing this speed decision to a desired speed range from 35 to 45 miles per hour. Now, select OK. We also will have trucks using this roadway, so we need to select a speed distribution for trucks as well. So select New again. The HGV vehicle class refers to trucks, and our trucks will have the same speed distribution as cars on this roadway, so we can select OK to keep these default values. Since our speed limit is not time-dependent, the speed doesn't vary per time of day, we can also keep the default values for time from and until. If we did have a speed limit that changed during our simulation time, we would simply need to create speed decisions for the different speeds and define at what time in the simulation the speed changed. Since these are the only vehicle classes that we will have using this roadway, we can now select OK. Let's now create one for Lane 2. Right-click on Point 2. You'll notice that VSIM has kept the values from the last desired speed decision that we had open during this session, the first one we created. We will use this temporary default to our advantage by creating all speed decisions with the same settings at one time. Select OK, and then left-click over the outbound NB link to select the link, and right-click and select OK over Point 3, which also has the same speed settings. When you are creating these in your own network, make sure to line these up quite closely so that vehicles on different lanes will cross them at the same time. If you allow a space between the speed decisions on the same link, it is possible that vehicles could switch lanes at just the right time and avoid crossing either speed decision. Also, make sure to place these on the link after all connectors have ended. If you place the speed decision on the link before a connector ends, vehicles on the connector will not cross the speed decision. With the placement we have now, westbound left-turning vehicles will not cross a speed decision. Points 5 and 6 will have slower desired speed distributions, since the speed limit is 30 miles per hour on the east-west roadway. Left-click over the outbound link eastbound to select the link, and then right-click over Point 5. In the dialog box, select Vehicle Class Car and select Edit. Using the drop-down arrow, select Desired Speed Decision 2, which has a range of 25 to 35 miles per hour. Select OK, and then follow the same steps to change vehicle class HGV. Now, when we create the speed decision on the westbound link, point 6, it will have the new default settings, so we can select OK to keep these. We still need to create a speed decision at point number 4. This speed decision should have the same desired speed distributions as 1, 2, and 3. So rather than editing the speeds again, since the default is now the same as 5 and 6, we'll take advantage of how vSim selects these temporary default settings. If we double left-click over speed decision number 3 to open the speed decision for editing, and just select OK to close the dialog box, the new temporary defaults will be like speed decision 3. So now, when we right-click over point 4, we will have the correct default settings and can simply select OK to create the speed decision. As with all network elements in vSim, if we right-click on the screen but not on any links or connectors, we will get a list box that lists all of the desired speed decisions in our network. If we select one of these in the list, we can edit the values for this speed decision by selecting Data. We can zoom to that speed decision by selecting Zoom, and we can delete that speed decision by selecting Delete. You can also delete a speed decision by left-clicking on the speed decision and dragging it off of the link or connector. If you drag the speed decision onto another link or connector, you will move it to that link or connector. Vehicles in vSim do not automatically respond to road curvature. To make a vehicle slow down for a turn or a curve, you must place reduced speed areas and define the desired speed distributions for these locations. Let's create reduced speed areas for the left and right turns at the intersection in our network. To make it easier to see where to create these reduced speed areas, we will switch to centerline view by selecting Ctrl-A so that we can see the background image in which we have added areas and numbers to indicate where each reduced speed area should be placed in this network. To create a reduced speed area, first, select the Reduce Speed Area icon on the toolbar. The Reduce Speed Area icon is the red triangle with the right turn arrow inside it. Now, left-click on the southbound right turn connector leaving the intersection to select the connector, and then right-click at the beginning of Area 1 on this connector and drag along the connector to the end of Area 1 in the direction of travel. In the resulting dialog box, select New to define the desired speed distribution by vehicle class. For a right turn, a good default turning speed is desired speed distribution number 20, which has a range from 12.4 to 15.5 miles per hour. So let's select vehicle class car and desired speed distribution number 20. If this were a very sharp right turn, we may wish to use desired speed distribution number 15, which has a range from 9.3 to 12.4 miles per hour. Using desired speed distribution number 20 for this reduced speed area will change the desired speed of vehicle class cars crossing this reduced speed area to a desired speed range from 12.4 to 15.5 miles per hour. Vehicles will start to slow down before reaching this area, such that they are traveling at the new desired speed once they cross the area. After crossing the end of the reduced speed area, their desired speed will revert to their previous desired speed, and if possible, they will begin to speed up or slow down to the previous speed at this time. Now, select OK. We also will have trucks using this roadway, so we need to select a speed distribution for trucks as well. So select New again. The HGV vehicle class refers to trucks, and our trucks will have the same desired speed as cars for this turn. So we will again select desired speed distribution number 20, and then select OK. Since our turning speed is not time-dependent, the speed doesn't vary per time of day, we can also keep the default values for time from and until. Since vehicles will begin to slow down before reaching this reduced speed area, we will want to make the reduced speed areas rather small. Increasing the length of the reduced speed area by too much can reduce capacity in your network. A good default length for most intersections is 6 feet long, so let's change the length of our reduced speed area to 6 feet, and then we can select OK to create the reduced speed area as we've defined it. Since vSim will remember our settings from the last reduced speed area created, let's continue to create the other 3 right-turn reduced speed areas to cut down on the number of steps to create these. Left-click on the eastbound right-turn connector to select this connector. Now, right-click on the connector at the start of Area 2 and drag along the connector to the end of Area 2 in the direction of travel. Since the default values for the speeds and time are correct, we only need to change the length of the reduced speed area to 6 feet and then select OK or Enter to create this reduced speed area. We will now follow the same steps to create reduced speed areas 3 and 4. To create a left turn reduced speed area, we will follow the same steps as for creating the right turn reduced speed areas, but in the dialog box, we need to increase the speed defined, since vehicles turning left do not have such a sharp turn and can therefore turn at a higher speed. If you have difficulty selecting a turn, use the scroll button on the menu bar or the tab button to scroll between overlapping links and connectors in the location that you last clicked. For a left-turning vehicle, desired speed number 25 is a good default speed and can be used for both cars and trucks. After we have edited the first left-turn reduced speed area, our temporary default settings will be correct for all left turns, so we can quickly create the other 3 left-turn reduced speed areas as we did before for the right turns. Using the Enter key after changing the length to 6 feet instead of mousing to the OK button speeds up this process. You can delete the reduced speed area by left-clicking on a reduced speed area and dragging it off of the connector. The Delete key will also delete the selected reduced speed area. Reduced speed areas can also be moved to other links or connectors by dragging onto another link or connector. We can also access a list of all reduced speed areas by right-clicking on an empty area of the network. The list box allows us to modify and delete any reduced speed area.